Uh, Greetings, Sanbonan. This is a video that I'm creating with the intention to try to assist physics students and whoever is interested in understanding physics. So today I'm planning to introduce the Newton's laws of motions, and I'm sure most people they are familiar with a physicist called Newton, Isaac Newton. So he proposed three laws which were the first one was already have been suggested by the Galileo, which is the Newton's first law, and he also proposed the second law, which is the law that described how the object move under the influence of the net force, and then he proposed the third law, which describe how the contact force between two objects manifest. So, uh, and also the last one, the law of universal gravitation. So I'm just going to start with the first law, and then we're gonna have another video discussing the second law. So yeah, this is just going to be like a freestyle. So I would appreciate your feedback. Thank you so much. So it will be bilingual. Sometimes I will use isiZulu terms for the purposes of clarity. So I hope this will be appreciated. All right. So we are talking about the uh, Newton's laws of motion. So these laws, they describe the motion. So we have the first law of motion, and this is also known as the law of inertia, or it's also known as the Galilean law. So basically, what it does is that suppose that you have an object, and this object is on the frame, say it's on the ground, uh, and this object, we want to understand its motion. So we have scenario A, and then we have scenario B. And scenario B, this object is moving with the velocity v to the right, with a constant velocity, and it's moving on a straight line. So what Newton's, even Galileo concluded is that this object will continue here. This is at rest. It's at rest or stationary. Stationary. Continue. Imile okanye ayinyazi. La, we can say this is a motion. Uh, iyanyaza. So there is movement, right? So what we can conclude here is that if we place this object and we come back the next day, it would be crazy to find this object having moved itself voluntarily. Like, for instance, you have a cup of coffee. If you place it here, you expect that when you come back, it should be where you place it, unless something crazy happened. So that is a logical thing to expect. And then scenario B says that if this object is moving at a constant velocity on a straight line, then this object should continue on that path or in that motion, unless something crazy happens. So there is no reason for this object to do otherwise. Now, by the object, we mean that this is excluding, uh, let's say it's an inactive, uh, 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 it's an inactive matter. So in other words, it can't voluntarily change its state of motion from uh, uh, by itself. So there must be an external influence. So there's no internal influence to cause this object to move in space. Yes, so there might be some chemical processes, but they are not strong enough to cause this object to move in space. So it doesn't have that strength or that will. So meaning that if it's set in motion on a straight line, it should continue in that motion at a constant velocity on a straight line, unless someone outside change it or some force change it. And if it's stationary, it should remain stationary unless if there is some influence from outside, right? So this is called the law of inertia because inertia is a tendency of an object to refuse to change its state of motion, whether it's at rest, which is stationary, inganyakazi or imile, or if it's moving in motion at a constant velocity on a straight line, or iyanyakaza, ihamba emgweni oqondile. So those are the two scenarios that we may have. So the tendency of an object to refuse to change its state of motion is called the inertia. So this law is called the law of inertia. So we will go further in future to look at how it end up influencing the Einstein theory of relativity and general relativity, theory of special relativity and general relativity. But for now, we can just summarize and leave the law to say that Newton's law state that if the object is at rest, ayinyakazi, if the object is at rest, it will remain at rest, or you want to say stationary, or ayinyakazi, ayinyakazi. It would remain at rest, or if the object, is moving at a constant velocity on a straight line, it must be on the straight line because this is a vector quantity. Maybe in future we'll discuss that because in the magnitude can be the same, like 60 kilometers per hour on a straight line. Because if it's moving on a curve, the magnitude is constant, but the direction is changing. So this does not obey the Newton's first law. So it must be moving on a straight line. So, or if the object is moving at a constant velocity on a straight line, it will continue on that motion unless there is an external, must be an external force or unbalanced force, or sometimes they say the resultant force. Yes. So this is your famous Newton's, let's put a different color, famous first law of motion. So let's highlight what is important. We are dealing with the object. It's at rest. Enyakazi, it will remain at rest. It must remain at rest. Or if it's moving, this object is moving, it must moving at a constant. It must be a constant velocity on a straight line. It will continue on that motion unless this is a condition. There is an external force because we've already concluded that this object does not have an internal will or power or strength to change its motion in space and time. Or there is an unbalanced force or a resultant force. So thank you so much. This is the first video on the series on the Newton's laws. So if there is something that you feel that it should have been discussed. You are free to make a comment, make a suggestion. Your comments are highly appreciated. Thank you so much. Siyabonga, siyabulela. Enkosi. Have a good day. Thank you.